All right, today we're going to tackle a really fundamental question in programming. Do you tell the computer how to do something step by step, or do you just tell it what you want? Now, that might sound like a small difference, but it's the key to two totally different ways of thinking about code: imperative and functional programming. These two ideas have shaped pretty much everything, from the OS on your laptop to the AI in your phone.
So let's just start right there. How do you tell a computer what to do? Now, if you're a computer science student, your first thought is probably, well, you write a list of commands, right? Line after line. But believe it or not, that is only half the story. There's this whole other way to approach it, a way that's less about the individual steps and way more about the final result.
And that really is the core of what we're talking about today. On one side, you've got the imperative approach. Think of this like giving a chef an incredibly detailed recipe. First chop the onions, then heat the pan to exactly 350 degrees. But on the other side, you've got the functional approach. This is more like just ordering a pizza. You don't care how they make it. You just describe what you want. I want a large pepperoni pizza, please. See the difference?
Okay, so let's start in the world that most of us, especially if you're a student, know best. This is the imperative paradigm, and for anyone who's ever coded in C, Java, or Python, this is going to feel like home turf. Imperative programming is really all about giving commands that change the program's state. Think about it. The three pillars of this world are variables, which, hold some data, assignment statements, which go in and change that data, and iteration, your good old for and while loops, which just repeat those changes over and over. It's just a sequence of instructions that are constantly modifying data. But have you ever stopped to ask why we think this way? Why is this the default for so many languages? Well, it is not an accident. This entire way of thinking, this whole paradigm, is a direct reflection of how a computer's hardware is actually built. And understanding that connection is the key to seeing both its power and its limits. You see, we program this way because our computers are built on what's called the von Neumann architecture. Variables, they're really just a friendly name for a memory cell. An assignment statement, that's literally the act of moving data from memory over to the CPU to do something. And loops are super efficient because you're just rerunning instructions on data that's being piped through that same channel. But this creates a really famous problem, the von Neumann bottleneck. It's basically a permanent traffic jam between your memory and your CPU, and it's the number one thing slowing your computer down. Okay, so now let's leave that familiar world behind and step into something different. Functional programming isn't just a new syntax to learn, it's a completely different philosophy for how to solve problems. In the functional world, the main way you get things done is by applying mathematical functions. That's it. You build your programs by sticking functions together, kind of like you would in a big math equation. And here's the absolute crucial point. The whole philosophy is built around avoiding changing state and avoiding mutable data. This entire philosophy really rests on a few simple, powerful ideas. First, you use what are called pure functions. That means for the same input, you are always going to get the same output. Guaranteed. This also means functions have no side effects. A function's only job is to compute a value and return it. It's not supposed to be changing some global variable on the side. And all of this leads to immutability. You don't change data, ever. Instead, you create new data. Now think about the last time you spent hours chasing a bug because some variable changed when you weren't looking. The functional world is designed to make that kind of bug literally impossible. Okay, so we've got these two very different philosophies bouncing around. To make the contrast super clear, let's put them side by side. It's time for the showdown. This table just crystallizes everything. Look at state. In the imperative world, it's mutable, it's shared, it's always changing. In the functional world, it's generally immutable. Don't touch it. How does data flow? Imperative modifies variables right where they are. Functional creates brand new data structures. And control flow? Imperative uses loops and conditionals. Functional uses function calls and, very often, recursion, where a function calls itself. The core unit of work is totally different. Now, this functional approach might sound all new and modern, but its roots are incredibly deep. Let's talk about LISP, kind of the elder statesman of functional programming. It shows just how powerful these ideas have been from the very beginning. I mean, check this out. LISP is the second oldest high-level programming language ever. It was born way back in the late 1950s. And it wasn't designed for number crunching, it was designed for symbol manipulation, for logic.
This made it the perfect tool for all the early pioneers in artificial intelligence, who were trying to get computers to reason with concepts, not just numbers.
And yeah, Lisp looks kind of weird. Everything is a list, inside parentheses. This little expression here shows its prefix notation. The function name, list, comes first. But here is the truly mind-blowing part about Lisp. In Lisp, the code you write and the data it operates on have the exact same form. They're both just lists. This powerful idea is called homoiconicity, and it means you can write a program that can analyze, transform, and even generate its own code while it's running. It's an absolutely wild concept. So is this all just a cool history lesson? Is it imperative versus functional and you have to pick a team? Not at all. Actually, the most exciting part of this whole story is seeing how these two worlds are coming together. Functional programming is not just some academic topic anymore. Its ideas are showing up everywhere.
In fact, I can basically guarantee that if you're a programming student today, you are already using functional ideas, probably without even knowing that's what they're called. That new world of functional thinking has already started merging with the familiar world of the imperative style you already know.
Come on, have you ever used a lambda function or a list comprehension in Python? That's a functional idea. Ever used the streams API in Java to map or filter a collection of data? Purely functional. C++ has lambdas now. And JavaScript? The whole language is built around the functional concept of first-class functions. These features have been adopted everywhere because, well, they're incredibly useful.
So why does any of this matter to you as a student? Simple. Understanding these functional principles will make you a better programmer, period. These features help you write code that is way more concise, much easier to read, and a lot more predictable because it cuts down on those nasty hidden side effects. This is especially true when you're dealing with big, complex tasks, like processing huge amounts of data or writing concurrent code where you can't have different threads tripping over each other.
And that leaves us with one final big question to chew on. As our programs get more and more complex, as they become more distributed, as everything becomes about data, are we slowly moving towards a future that is more and more functional? Is that old way of telling the computer how to do things finally giving way to simply describing what we want? That's something to think about. Thanks for tuning in.